For generations, we've looked up at that little red dot in the night sky and just dreamed. We've dreamed of taking Mars, this cold, dusty world, and breathing life into it. The idea of turning it into a second Earth, a brand new home for all of us. It's a really powerful, really romantic idea, isn't it?
And hey, this isn't just science fiction anymore. I mean, we have some very serious people with very serious money talking about how we could actually do it. The popular vision, the one we all know, is all about warming the planet up, melting the ice caps to create oceans, and thickening the atmosphere until we can just walk outside and take a deep breath. It's a really compelling ambition.
Okay, so let's get into it. Because when you strip away all the sci-fi glamour and just look at the hard, cold data, a very different and way more challenging picture of Mars starts to come into focus. It is definitely time for a reality check. So, our first problem, and honestly, this might be the biggest deal breaker of them all, isn't about what Mars has, but what it's missing. See, every living planet needs a shield to protect it from the absolute harshness of space, and Mars just doesn't have one. This slide right here gets to the absolute core of the difference between our two worlds. Here on Earth, we've got a spinning, molten iron core that acts like a giant engine, generating a powerful magnetic field. It's our own invisible force field, and it deflects this constant, brutal stream of high-energy particles from the sun called the solar wind. Mars, on the other hand, its core cooled down and solidified billions of years ago. It's geologically dead. And no spinning core means no global magnetic field, no protection, none. And the consequences of having no shield are just profound. It really is like trying to fill a bucket that has no bottom. Any atmosphere we could ever hope to build would just get relentlessly blasted away by the solar wind and stripped off into space. We'd be fighting a fundamental force of physics with a planet that lost its only defense eons ago. Okay, but let's just pretend for a second. Let's say we could magically invent a magnetic shield for Mars. We'd still face another massive, massive problem. We simply don't have the raw materials we need to build an atmosphere in the first place. You've probably heard this one. It's been most famously talked about by Elon Musk. And the concept is, well, it's audacious, to say the least. We just detonate a bunch of thermonuclear weapons over the Martian poles. So the thinking goes like this. The massive heat from the explosions would instantly vaporize the polar ice caps. That would release huge amounts of carbon dioxide that are trapped there as dry ice. This CO2 would then act as a powerful greenhouse gas, thickening the atmosphere, trapping heat, and kicking off this runaway warming effect. It's the ultimate planetary jumpstart. Right, so here's the multi-billion-dollar question. Does the math actually work? Let's forget about how we do it for a minute and just focus on what we're working with. How much carbon dioxide is actually locked away on Mars that we could possibly release? Well, thankfully, we don't have to guess. NASA has already done the homework for us.
After years and years of analysis from missions like the Mars Reconnaissance Orbiter and MAVEN, NASA has the answer. And it's 7%. That's it. That is the hard, physical limit of the atmospheric pressure we could ever hope to create.
And let me be really clear about what this number means. This isn't just about melting the ice caps. This number, 7%, is what we'd get if we could magically liberate every single molecule of CO2 on the entire planet. The stuff in the poles, locked in the rocks, buried deep in the soil, everything. The absolute best case, most optimistic scenario leaves us with an atmosphere that has only 7% of the pressure we enjoy here on Earth. And here's what that looks like visually. I mean, it's stark. Compared to Earth's thick, wonderful atmosphere, the absolute maximum potential for Mars is just this tiny little sliver. It's next to nothing. This isn't an engineering problem that we can solve with a clever gadget. It's a fundamental inventory shortage. The stuff just isn't there. An atmosphere at 7% pressure is so thin, it's practically a vacuum. It couldn't possibly trap enough heat to warm the planet in any meaningful way, and liquid water couldn't exist on the surface. It would just boil away. And worse, for us humans, the pressure is so low that without a full-body pressure suit, the nitrogen in our blood would literally start to bubble and boil. It's a completely unsurvivable environment. So, Mars has no shield and there isn't nearly enough air. But even if we could somehow solve those two planet-sized problems, we'd still have to deal with the ground beneath our feet. Because, as it turns out, the soil itself is toxic.
The entire surface of Mars, pretty much everywhere, is saturated with a class of chemicals called perchlorates. Now, we do have them here on Earth, but on Mars, they are absolutely widespread and in much, much higher concentrations. And these things are just bad news. They're poisonous to humans, for one. They specifically target and disrupt the function of your thyroid gland, but beyond that, they make agriculture basically impossible. Martian soil as it exists today is a poison to Earth-based life.
I mean, really think about the scale of this problem. Before you could even dream of growing food to support a colony, you need some kind of planetary-scale industrial operation just to detoxify the soil. We're not talking about filtering a few buckets of dirt here. We are talking about chemically scrubbing an entire world.
So, when you add it all up, a missing shield, not nearly enough air, and literally poisoned ground, that grand, beautiful dream of terraforming Mars, well, it starts to crumble under the sheer weight of scientific reality. These aren't small engineering hurdles we can just solve with some clever invention down the line. No, these are fundamental, unchangeable properties of the planet itself. There's no shield to protect an atmosphere. There's not enough gas to create an atmosphere. And the surface is poisonous to life as we know it. I think this quote from the source material just sums it up perfectly. We often like to think of Mars as Earth's slightly broken sibling, right? A fixer-upper that just needs a little bit of work. But it's not. The hard truth is that Mars is a fundamentally different kind of world. Its planetary evolution just took it down a completely different path billions of years ago. We aren't fighting some recent problem. We're trying to reverse billions of years of geology and planetary physics. And this leaves us with a really fascinating final thought. If we accept that we can't turn Mars into Earth, the whole challenge shifts. The new goal isn't to change the planet to suit us. It's to use our technology and our ingenuity to adapt to the planet as it truly is. And you know what? Maybe that's an even more interesting challenge, after all.